In this video, I will demonstrate the essentials about components connections and their manipulations through the connection page. Let me start first with machine definition, and in this particular case, a spindle. Each spindle actually consists of one or multiple stations, and in this case, the spindle has only one station defined as with origin and the coordinate system with its direction. Inside the toolkit, we have a component such as holders, shanks, and fixtures that have always two coordinate system. We call the upper one the mounting point, which is actually connection to a higher component. And if we take such a holder and mount it to a spindle, those two coordinate systems will actually match. Another coordinate system we call actually a joint point, and this is actually connection to a lower component. Additional components can be defined, and each of them have all the same rules, two coordinate systems, the mounting one and the joint, except of the cutter. There is no component that can be attached to cutter, therefore the cutter itself has only one coordinate system, and in the case of milling tools, the Z goes up, and those rules I'm going to repeat in some of our coming videos. Everything below the cutter is nothing but a cutting point. If we do assembly of these components, we are going to end up with an assembly with ToolKit structured as so and demonstrated in the machine preview, as you can see it here on the right. So let's see how we can manipulate this inside the toolkit and how to do that. And inside the toolkit, I'm going to select this tool assembly that includes two components, the holder itself and the cutter. I'm also going to keep my machine preview active and also tool viewer active. And while selected each of the components here, you can see the coordinate system change. I'm going to click on the holder, and the same will be demonstrated. The coordinate system of the STL is located over here, while we also have our joint defined here with a joint name. Similarly, if I click on the cutter, I'm going to see only the coordinate system of that cutter. Right. How we can manipulate with locations of these cutters and these components in the assembly. You can go to the connection page. You can find it over here, and connection page can be different depending on what component is selected. But the main component looks like so. This is a connection page of holder, and it is divided into three, let's say, areas. The first one is manipulation of the mounting, and other is the joint list. Depending on what joint is selected, another joint components can be defined over here. Right, so let's see what we have here. Our holder is connected to this joint, which we call a station, and there are fields here that you can define shifts along the X, Y, and Z, also rotations around X, around Y, around Z, and you can do that in way of writing the value here, or you can just use simple scroll wheel. Well, the same will be applied. Please note that dynamically in the machine preview we can see the results immediately. Also, if you're holding the shift key, the delta is actually 10 and so on. We can also apply also rotations, but if you don't like these values and you want to reset and you don't want to spend time by writing this all to 0, you can also go to these three dots here and reset the whole mounting page, or you can only the position or the orientation. So I'm going to reset all to 0 and continue. As we said, every of holder components must have at least one joint. Later in this video, I'm going to show you how you can define more joints, but the whole manipulation is done by the right click here, where we can add or set joints to be static, which I'm going to use mostly in this video. And also we can define a rotary axis and linear axis, which will be demonstrated in some other videos. Depending on each joint, while selected, the joint properties are listed over here. we can clearly see that this joint has been shifted along the z-axis for 160 millimeters, respecting to its reference coordinate system here. We also have a drive unit type, which describes direct connection of the driver in the spindle. And there are 4 options that you can see here. Either it goes directly, which means that if we have a motor in the spindle, this whole holder will spin and rotate as well. We also have not driven in the case like turning tools, then I will define this holder as not driven. We also can define a self-drive and also gear. Gear will be very common example when we have holders attached to a revolver. They are not directly mounted, but as a gear with potentially some ratio, which can actually change either the spin rate or the spin direction itself. Right. So let's manipulate a little bit with a joint, and we can see over here the cutter. And if I click on the cutter, the connection page is slightly different, and it demonstrates only the connection to a joint. And above component here, it has only one joint. And this mounting shift is displayed over here. This mounting shift, it's nothing but outside holder length defined over here. For the milling application, that is the case, but it doesn't need to be case for any tool assembly. So I'll just go to the connection page, and if I just change over here the value, we can dynamically see that it has influence regarding to the joint connection. So let's now go to holder itself, and I want to manipulate with the joint. So if I go here and change the joint location, you can see dynamically that joint is changing, but also all the components below that change the locations as well. So let me just show you how we can add more joints, but not on this example, but on example on the revolver. So in this case, I'm going to use other components. I'll go to SolidCam tool component library. Actually, that's in the milling STL holder. So I'm going to use not this example, but let's say this example. This is a clear example where we should have 2 joints, and over here, this joint is not properly defined. So let me just again activate my machine preview. I'm going to attach this to, let's say, station number 10. So I'm just going to drop to the station number 10, and I can see it over here. I will orientate it in the same way as I can see it here and provide and make a manipulation with the joint. I'll click on connection page, and as you can see, I can't change anything because this is coming from my library. So I'm going to delete the link and do manipulations now. So first of all, this joint, let's call him left joint, as I'm going to shift it along z-axis and place it over here. And before I do that, my drive unit type, as I'm going to use this as and I can use here the end mill or drill. Let's imagine that this is also has a gear inside. I will either define it as not driven in the case only drill tools can be used for the center turning, or I will use here a gear option where I can define my maximum spin and also provide a ratio to it. So let's, in this case, imagine that this is going to be a gear. And along the Z, I will define the shift. And I can do shift like so, or I can simply click on this field over here and go to the tool viewer and just simply select on the 3D model. Click, click, and there you go. So you don't need to guess what are actually the actual values. On top of this, I'm going to add another static joint that I'm going to call right. And in this case, I'm going to shift it along Z as well, but the coordinate system must be properly defined while Z must go in this direction. To do that, I can rotate it manually, or I can also provide the Z vector, click over here, click over there, and the Z axis will be normal to that surface itself. Right. Now, if I have this one, I can, for the right joint, I can make also the ratio to be reversed in the spin direction. Okay. We got nothing left but to define two cutters on this component where it will go automatically to the first one or to the left one. I can add another ball nose mill that will go automatically to the right one.